My name is Artem Sharko. I am presented our work. Intelligent system of optimization, maritime transport development management under conditional of multi-criteria and accidentally of input information. A solution to an important scientific and practical problems is present optimization of maritime transport development management and the conditional of multi-criteria and unsincerity of input information. The paper presents methodology of select optimal diagnostic and operation parameters under multi-criteria condition and input information unsincerity. The novelty of the methodology is compilation of an effective matrix. The raw watch are represented by statistical characteristics of vibration signals. Columns by criteria of statistical solution of Laplace, Waltz, Fourier's, additive and multiplicative and additive multiplicative convolution, and its elements by practical result. Slide number 2. The aim work is to develop intelligent maritime transport management system and approaches to assessing the diagnostic and operation parameters of transportation. The active development of work rate is characterized by the emergence of new forms of interaction, global transport system, and the emergence of global logistic initiatives. The process of globalization is characterized by high complexity and non-linearity of the configuration of logistic system. The specifics of transportation require a constant exchange of information. The main task of identifying and determining the result life of vessels during operation is the monitoring changes and the mechanical properties of materials with the accumulation of damage and determine the parameters of procedures of the occurrence of information signals during equipment destruction. Vibration diagnostic is the most effective method for determining the technical condition of various rotor type mechanisms. Vibration signals are multi-complement. There are a finite additive set of multi-scale components localized by frequency bands of different types of vibration. Optimization of the management of the development of marine transport in condition of multi-criteria and uncertainty of input information is one of the unsolved problems of information theory, solid state mechanisms, and physical acoustics. The materials used were the effectiveness of diagnostic and monitoring of the equipment and operation. The method used the multi-criteria analysis, game theory, and statistic decisions. The effectiveness of monitoring directly depends on the rate of defects development and can be determined by optimization parameters based on the change in the trajectory of main diagnostic parameters. These parameters can be used as raw of the effective matrix. The effective matrix has been formed 1. Relative deviation is future from 2 and optimization values is determined as follows. Is C for G is necessary to choose the best values of the analogous parameters from the point of view of the problems being solved. This can be maximum or minimum from experiment sample. With this approach, formula with convert dimension quantities in the relative on within the castle 0.1. The criteria of statistical decision theory can be used as supplements of the efficiency matrix. In this present formula of table rho proximity index, which in conversation calculation is taken to be equivalent to 0.5. Omega j weighting coefficient of the j optimization parameters. The main strategies of construction a multi-criteria approach to selection optimization diagnostic characteristics for monitoring ship bearing are working with quantitative experimental information, mathematical calculation, storing, exchanging information, and interpreting the results. The measurements are taken on the bearing unit housing, namely its lower part, since the load on the unit are maximum here. The signal from the sensor can be digitized and recorded from the trend analysis. An accelerometer is used to record vibration levels. Vibration signals less 6 seconds was recorded daily from 15 days in a row. A bearing modification occurred which led to its failure. All of the listed statistical characteristics of vibration signals can serve as potential indication of bearing conditional degradation. Slide number 7. The failure in smoothing prediction was applied to the extracted statistical characteristic. In order of the determine the most optimal characteristic from monitoring the condition of a shielding bearing, a multi-criteria optimization was carried out using 5 parameters with different weight factor omega. Monitoring omega is 0.25, sensitive omega 0.25, rate of linear change omega is 0.20, deviation from identity omega is 0.15. Area under curve omega is 0.15. The result of collection of optimization parameters for each statistical characteristic of vibration signals are present in table. Relative deviation calculation using form parameter of statistical characteristic of vibration signal from the optimization value as well as the value of convolution and criteria are present in table. The analysis of the results present in table show of the additive convolution, multiplicative convolution, additional multiplicative convolution, Laplace and Wahl's criteria clearly indicate that peak factor, peak to peak, is the most optimal characteristic from monitoring the state of soliding bearing. The creation of vibration diagnostic methods involves the initial structure of a physical models followed by diagnostic models, which use deterministic and probabilistic methods. In diagnostic analysis models, monitoring the condition of bearings becomes possible when a database and modern expert diagnostic system use complex algorithms from processing and filtering signals. Taking into account the vibration justification of the range of the change and reason for the need to optimize the values that transpiration parameters are determined. Using this information make it possible to complete an efficiently matrix and perform the corresponding calculation. Thank you for your attention.